So, uh, good evening, all. So, just let me share my screen. Is my screen visible?
Not yet, sir.
Ah, my screen is visible, right?
Sir, yes, now it is visible.
Yeah. So, welcome to the final session of this course, NPTEL course, Geotechnical Engineering 1, handled by Professor D.N. Singh. I am Yogendra Narayanan. I am a PMRF research scholar. So, who has been taking this session, and finally we are at the end of this problem solving session. So to give a brief introduction of the purpose of these sessions or is these sessions have been designated uh, uh, to increase the proficiency of in, uh, increase the understanding of the learners uh, in the particular subject by conducting weekly sessions of the containing the syllabus that has been covered in a particular week by solving problems and some conceptual questions and creating discussions uh, and thereby it helps the learners to uh, uh, it helps the learners in approaching the NPTEL exams as well as the future competitive exams and in their future professional endeavors. So this is the final session, week 12. So to give a brief overview of what has been covered in this week is time rate of consolidation, uh, which is the extension of Terzaghis one-dimensional consolidation, that the differential equation, the solution of the partial differential equation uh, gives what understanding of the behavior, time dependent behavior of the soil. So several concepts relating to that and new terminologies such as time factor, coefficient of consolidation, degree of consolidation has been discussed, and how to compute them uh, were also taught. So based on the contents of this particular week, we will be solving some of the problems and as well as some discussions on some conceptual questions. So moving to the session today. So we have some questions on the concepts. So in a soil sample of a consolidometer test, pore water pressure is the where will be the maximum pore water pressure, or what is the magnitude of pore water pressure existing at various point in a consolidometer. So option A is minimum at the center, option B is maximum at top, option C maximum at the center, and D is maximum at the bottom. Any answers? Any answers? Any insights?
Sir, what are the drainage boundaries?
Sir,
So it is a double drained. In a consolidometer test, it is usually double drained.
Default, we have to assume like that.
Yeah. It is double drained in consolidometer test because we place both
double check.
porous stones at the top and bottom of the sample usually.
Okay, in that case, maximum at the center.
Yeah. So if you draw the pressure distribution, this is the sample. So here there is a porous plate, or this is one of the drainage layers, and at the bottom also we place a porous plate usually. So this is also a drainage layer. So if this is the neutral point, then it is a parabolic curve with excess pore water pressure having magnitudes 0 at top and bottom, and this is U bar maximum. U bar corresponds to excess pore water pressure, so it has a maximum of uh, maximum magnitude at the center. So if in this case, if we place by an impervious layer here, then what is the condition? What will be the how it will change?
It will be triangular, I think.
It
Zero already.
usually we it is simplified as triangular, but usually it is a parabolic curve only.
Okay.
Yeah. So it will be, if it is an impervious layer. So there are you can the expression of this parabolic curve can be found in a book called Malcolm Bolton. So this
Oh,
at here it will be U max. Here it will be 0.
okay.
Right, for a single drainage condition. This is double drainage, double D, and this is SD, single drainage condition. Fine. Any doubts? Any clarifications are required?
Normally in single drainage, they don't ask at the middle lesson, they will ask only at the boundaries.
Yeah, yeah, at the boundaries. Yeah, yeah.
Okay.
So the right option is maximum at the center. The asked question is for double drainage. And also, if you see laboratory testing usually we do it as a double drainage condition test, unless specified. For example, if you are demonstrating to students, usually the procedure is that they usually keep porous stones at the top and bottom of the sample, and the entire oedometer cell is kept in a water bath for saturation. So that is how the test is being demonstrated, or it is usually taught in fundamental laboratory courses. So in this case, if you, in your exams, if consolidometer test is specified, you can assume it as double drainage. Otherwise, unless otherwise specified particularly that it is a single drainage condition. Hope it is clear. And you can write the assumptions also such that the evaluation is done and is done accordingly. You can write as in a bracket that you are assuming a double drainage condition.
Okay, sir. Done.
Fine. So this is the right answer. So coming to the next question, the log of time method is suitable for dash soils. So log of time method. So what does log of time method used for? What is log of time method used for? For
Sir,
what
who
for
has
what?
to answer? Who has to answer? There are two people.
Hey, anyone, whoever.
Okay. Then answer is fine grained soils with a very low permeability.
Yeah. So log of time method. There are use this log of time method is one of the ways to compute CV, coefficient of consolidation, right? So how is it usually done is, usually it is plotted at the uh, for each loading increment, the uh, dial gauge readings is plotted with time. So in this case, there are two methods of extracting CV from this curve. So usually it will be a exponential curve. There is two methods. Either the x-axis can be root of time or log of time. Any reason why we use log? It's a simple common sense or a simple uh, uh, what to say, simple approach. Why we are using log?
To accommodate more timing.
Yeah. So the simple reason is that uh, the log of time, as you rightly mentioned, the answer is fine grained soil with very low permeability. So this is the right option. So if we consider very low permeability, usually it takes a very large amount of time for the consolidation to occur. So in order to accommodate the entire scale of time in a single graph, usually the x-axis of this graph is usually taken as in log scale. So that is why it is the logarithm of time method, as well as the with some high permeability we go to square root of time method. So how will you extract CV from here? Any idea?
Actually, the curve is different, no, sir. You will get a concave and convex support curves.
Yeah, usually it will be like this
Hmm.
exponential curve. So there is a proper procedure for it, right? So
Yeah.
to get the CV at for 90-degree consolidation,
Yes.
90% consolidation.
Yes, sir. Yes.
So usually what we do is we draw a tangent to the initial curve here
Increase the slope by
uh,
15%.
to slope, and what we do is uh, we how to put it? So we draw a parallel line at 1.15 times, right? So the 1.15 times 15% time where it meets in x-axis, that is taken as T90 usually. So this is how T90 process T90 is usually computed, right? So it is just for your information. So but the reason for choosing logarithm of time is to accommodate larger scales of time in a single graph. All right. So moving to the next question.
Sir,
Yeah.
small interaction in the previous slide.
Yeah. Just go to the tell me.
Option B,
Yeah.
B and C both are fine grained soils.
Yeah.
Here, what is the meaning of slightly high permeability? Is it an indication of some clay silt or something?
Yeah. With some silt content having uh, maybe qualitatively high permeability. That's all.
Okay, okay,
Yeah.
right.
So coming to the next question, the portion of graph representing OC behavior and virgin compression behavior is. OC behavior is during unloading, to be clear, to be to give the context here.
So part BC is for over consolidated behavior.
Yeah. So what does
Unload.
so let us discuss this entire curve here. So what does DA signifies? There are three demarcations, right? There are three parts to this curve. So one is this one is this one, and one is this one. So as you write, let us come from this. The loading is done in this path. So what does D to A signify? Any idea?
Flatter portion is
Sir,
OC behavior.
initial
So
compression.
BC is OC behavior, as you rightly mentioned. Usually the loading path is taken as like this. And further, if you go for another loading cycle, so then the curve will be extended like this. Right. So, sorry, this one is like this. And then this is the second cycle. Right. So here D to A is a zone of initial compression. So it gets accommodated to the applied load initially, which is the change is very minute. So it is a part of initial compression, and followed by A to B is the virgin compression.
Virgin compression.
And once it reaches B, we are unloading it. So that means it it rebounds to an extent which follows a path of 3. So in this case, once it is getting unloaded, it starts behaving as, or it starts showing over consolidation behavior. So it does not reach its initial voids ratio. And once again, if it is reloaded, the voids ratio changes will be very minimal. And once it reaches, then this part will be the pre-consolidation pressure. So B will be pre-consolidation pressure for this particular cycle. And once it starts exceeding B, then again it is virgin compression for this cycle. Any doubts? Any doubts here?
Fine.
So the
Where is
portion of
OC, sir? OC is where?
OC is this part here.
Symbols are given, sir. O is given somewhere. No.
No, no,
Oh, over
representing
consolidated.
OC
Sorry.
is over consolidated
Sorry,
behavior.
sorry. I confused that.
So usually then the answer for this is portion of graph representing OC behavior is, for the given graph, is BC, right?
Okay. Understood.
And the portion of graph representing virgin compression behavior is
AB and continuation.
A to B.
Hmm.
All right, fine. So moving to the next question, PVDs are installed in ground for what purposes? What does PVDs mean to start with? What does PVDs mean?
Prefabricated vertical drains.
Yeah. So PVDs are prefabricated vertical drains. So what does it do? Usually it is used to as a ground improvement technique to accelerate the process of consolidation. So how does it do?
Reduces the drainage path.
Reduces the drainage path, which leads to
Reduce the time taken for consolidation.
reduce the time taken for consolidation. That is increase the rate of consolidation. So option A is right. So that means option B is not. Increase the coefficient of consolidation, obviously. So CV depends on K divided by MV into gamma W, right? So once we install PVDs, so obviously the entire permeability aspect along with KV, KH is also added. Not added in the sense not in a uh, arithmetic manner, but it is a uh, it acts as an increased contribution uh, to the increment in or the rate of consolidation. So which uh, results in the increase in coefficient of consolidation also.
Sir,
Yeah,
here the increased coefficient of consolidation means default is going to be CV or CR or C horizontal or both.
both. In this case, PVDs, it will be
Both.
resultant coefficient of consolidation, which will be both.
Okay.
Yeah.
It means final option is D, na?
Yeah. The right option is both A and C.
Okay.
All right. So moving to the next question, match the list 1 with list 2. So this is separate. The right side question is separate. So this is list 1 and list 2. Coefficient of compressibility and how it is determined. So list 1 is the various parameters and list 2 is how it is determined. So how is coefficient of compressibility determined? What is coefficient of compressibility?
AV, sir. Delta E by delta sigma.
Yeah, that is AV. So coefficient of compressibility is AV. Compression index is CC. Coefficient of consolidation is CV. So how is AV is defined as delta E by delta sigma dash. CC is defined as delta E by log sigma 2 dash by sigma 1 dash. Coefficient of consolidation is determined from the already we discussed about this. We usually get it from dial gauge reading versus time. So coefficient of consolidation is this one. Coefficient of compressibility is stress versus voids ratio. So this is this one, and compression index is logarithm of stress versus voids ratio. All right.
Okay, sir.
So coming to the next question, instrument used for calculating the coefficient of radial consolidation is. Instrument used for calculating the coefficient of radial consolidation is.
Rosal.
Yeah. So that is oidometer is a normal one-dimensional consolidation what we use. So it has a circular ring where samples are kept, and usually it is covered by two, it is surrounded or it is sandwiched between two porous stones, and the load is applied. So it is used to study one-dimensional consolidation or simply vertical consolidation. So this is not right. So coming to Casagrande's apparatus is used to study liquid limit. So this is not right. So triaxial apparatus, it can be used to study coefficient of consolidation, but not radially. So it also has a limitation of studying only vertical consolidation only, because the reason being the triaxial cell, you might not have been, those who are studying the undergraduate students would not have been exposed to triaxial testing still. So usually the triaxial sample looks like this. So the height to diameter ratio is 1:2. So and it is uh, confined around all the sides, confined on all the sides by applying some pressure, and there are some ports to collect the excess pore water that is being generated due to the application of the pressure. All right. So it is only uh, the uh, it also has, since these boundary conditions are rigid or it does not allow, it is covered by a rubber membrane, so it does not allow the flow of water in and around the from and uh, to the sample in the radial direction. It is also used to calculate only one-dimensional consolidation coefficient. So this is also not right. So Roye cell is used where in a small modification is done to a oidometer cell, wherein what we do is we have a sample holder which is slightly larger in size, but I don't remember the size exactly. We have a drainage well kind of thing in between, and this well is connected to the water. Uh, it is drained here. So and when you apply loading, you have dial gauge, and when you apply the loads, so the excess pore water starts to go move towards the, it is kind of drainage well. Why? Because here, due to the application of load, the water pressure is higher, whereas in this well, since it is exposed to the atmosphere, it is at atmospheric pressure. So the head difference will drive the pore water, excess pore water, to move from the point of high pore water pressure to atmospheric pressure. That is how the entire process is simulated in the laboratory by using ROSL. So the instrument for calculating the coefficient of radial consolidation is ROSL.
Can I have a doubt?
Yeah, please.
In this, you don't have a top and bottom porous stores. No? You don't have any vertical drainage when you're doing horizontal drainage.
Yeah, usually it is yes,
Okay, it is closed on the top and bottom. We allow only
only
radially to centrally it will
radially.
reach.
Yes, yeah.
Okay, okay.
So moving to the next question. The settlement analysis for a clay layer draining from top and bottom shows. So this question we have studied, we have discussed in the last class itself, I remember. So usually to understand consolidation, there are two aspects. Now you have been exposed to two parts of consolidation, which is the entire consolidation concept can be divided into two parts. So one is magnitude, second is time or rate. So you can derive its analogy from it is kind of a it is analogous to a vector quantity where you have magnitude and direction, whereas here it is a time dependent phenomena where you have two uh, parameters which is necessary to establish this phenomena, which is magnitude and time or rate. So magnitude is the settlement, total settlement, which depends on the compressibility of the soil, which in turn depends on its mineralogy, uh, thickness of diffuse double layer, and permeability, etc. Not permeability, so initial voids ratio, I would say. So it's a function of the settlement will be the first function is applied effective pressure, voids ratio, and then would say Cc, which is the material property. So whereas time rate is how much time it takes for this magnitude of settlement to occur. So that is governed by several parameters. Usually we go by time factor, and which depends on permeability of the soil. So same compressibility aspects and fluid properties also. So because if you have any other pore fluid, for example, if you have uh, water in place of water, you have any other fluids like it may be some non-polar fluids like kerosene, CCl4, ethanol, etc. So its behavior will be completely different in consolidation. So it also depends on fluid properties, and it gets included in the form of its unit weight, gamma W. So that is also uh, and one of the important properties which we usually miss, because in general practice it is only only fluid which we come across is water, right? So here you can see here this part, the magnitude part is highly dependent on the applied load and initial conditions. So applied load and time is dependent on the permeability aspects. So this becomes the hydraulic aspect, and this becomes the mechanical aspect, right? So in both these are complementing each other. So this is one of the fundamental examples of the phenomena which comes under the term known as hydromechanical coupling. So this is the one of the fundamental examples of hydromechanical coupling. And if I introduce, and this entire thing occurs only at, we assume it as room temperature. So if I give you a situation, what will happen at higher temperatures? Any idea? So we are just extending this whatever concepts we have learned to one step ahead. So any idea what will happen if we change the temperature?
Permeability increases
Why?
directly proportional to.
That is one of the points. One major thing happens here. What happens to a material when you increase the temperature?
Dryness.
It tends to expand, right?
Okay.
So then if you consider water in pores and if you raise the temperature, what happens to the water here?
It will be in pressure.
It tends to expand, which will contribute to an enhanced pressure apart from the pressure that is due to the applied load, right?
Okay.
So here in that case the generated excess pore water pressure will also be more, and increase in temperature will decrease the viscosity of the fluid, and hence K will permeability tends to enhance, and hence this entire interplay between the applied load, the permeability and the temperature is what which comes under the terminology known as thermo-hydro-mechanical coupling. So this is
Okay.
one of the major research areas which is being taken, which is being concentrated in this particular in recent times. This is uh, in a short form which is known as THM behavior of geomaterials. This is known as THM behavior of geomaterials. So if now people have tried to simulate this type of behavior in both laboratory, and those results have been used to verify the numerical models which several researchers have developed to understand this phenomena, and what are all the effects of different type of mineralogy present, different type of pore fluid present, what happens if there is a gas present. So these are some of the branches which people are exploring it right now. All right.
Oh,
So
okay, sir.
So not only increase in temperature, also decrease in temperature. If we
No.
freeze it, what happens? So those things are also being concentrated right now to understand the exact behavior of the material itself, right?
Okay.
So even though these are all not directly involved in conventional practices of geotechnical engineering, but these are some uh, what to say, these these topics have applications uh, in energy extractions and concepts like that, but not deliberately in infrastructure development. All right. So if you pursue further your higher studies, so this is one of the good areas to explore, and it is being explored now. So under various context, so it is being explored. All right. Okay,
Okay.
so slightly we have gone off topic. So I just wanted to introduce this so that learners get fair idea, and maybe some of them would explore more in this vertical. So coming to the next question, if the drainage length doubles, the time for 50% consolidation uh, happens to be. What about the time taken for 50% consolidation if the drainage length doubles?
Drainage length doubles means it's like a equivalent to single drainage, no sir?
Yeah, it may be. Yeah.
Okay.
So time usually is TV is going to remain the same. So it is CV T by D square, and CV is same for the material and for the particular degree of consolidation. So only aspect is the variation is T and D square. So what happens is that if drainage length doubles, so T is directly proportional to D square, right?
Yes, sir.
If drainage length doubles, so if D becomes 2D, so what happens to time?
4 times.
4 times. T2 becomes 4T1. So since drainage length has an increased importance in the uh, entire process of consolidation, which is revealed by its square second power, right? So D square. So its increase or decrease plays a major role in controlling the entire behavior of consolidation, right?
Sir,
Yeah,
here the time for 50% consolidation they ask for, no?
yeah.
But the question settlement in 4 years is given, ultimate is given.
No, no, it is not related to that question usually.
Okay, this is different question.
Yeah, it is different question. So that
Uh,
is already we discussed this question earlier, so that's why I did not concentrate on that.
okay, okay,
So
okay.
this is a general question.
Okay, I got it, sir. I got it.
Yeah. So coming to the next question. So this is also not related. This is an independent question.
Okay,
So
okay.
time factor for 40% consolidation for a saturated clay layer is. So what is the relation we use for calculating uh,
Degree of consolidation.
TV time factor
5 by 4 u square.
for what is the condition for using
Less than or equal to 60%. When u is less than or equal to
yeah.
60%.
First TV is computed as pi by 4 u by 100, where u is in percentages square, for u less than or equal to 60 percentage, right? So for greater than 60 we use the relation
781
1.781 minus
933
0.933 log of u 100 minus
U.
u, right?
Yes, sir.
So we require time factor for 40% consolidation. So since it is less than 60%, we use this relationship. So what is the time factor we get?
Point 125.
So PV is 0.125. What is the unit?
No units.
Yeah. So since CV is meter square per second and D square is meter square and time is seconds, so everything cancels out and it is a mere number. Coming to the next question. A 10-meter clay layer is sandwiched between two sand layers and subjected to a uniformly distributed load of 100 kPa. If the coefficient of consolidation is 0.005 centimeter square per second, there are three sub questions. First is, what is the length of drainage path?
5
Just
meters.
uh, give me a minute. Just I will be back. Fine. So let us draw the question given here. All right. So there is a clay layer of 10 meters sandwiched between. So well, it is not defined. So we take it as some imaginary extent at the top and bottom. So here it is clay, and here it is sand, and here it is sand. So sandwiched in the sense It is placed between two layers. So in this case, what type of drainage is it?
Double drainage.
It is a double drainage condition. So in double drainage condition, what is the drainage path?
H by 2.
H by 2. So coming to question A, drainage path, it is a double drainage condition, right? Double drainage condition, and hence D is equal to H by 2. H is the thickness of the entire layer. This is 10 by 2, which is 5 meters, right? So now what will be the time required for 50% consolidation? So U is 50%. How will you calculate time? Only relation which we have is TV is equal to CV T by D square, right? So TV you can find it because you know the degree of consolidation here, right? So what is TV? TV is equal to pi by 4 into U by 100, where U is in percentage, whole square. How much we are getting for this condition TV?
0.196.
0.196. So equate it to this relation, 0.196 is equal to CV we know, which is 0.005 centimeter square per second into T divided by D square. This is
500.
5, which can be converted to 500 square. Now you can calculate T. How much it is coming?
113.42 days.
113.42
42
days. You will get
days.
in seconds, then you have to convert it into days by dividing it by 86,400 seconds. All right.
Yes.
Now coming to the question C, it is similar to question B, only the relationship which we change is TV is equal to 1.781 minus 0.933 logarithm of 100 minus U. All right. How much we are getting TV?
0.848.
Yeah. So
848.
0.848. And what about so this will be equal to 0.005 into T divided by 500 square. How much we are getting? T
490.74.
490.
Yes.
You can take it as 491 days.
Okay.
Days
Yes.
can be this one, so you can round it off. 491 days is
Ye-
almost almost 1.3 years, and this will be around 114 days. Right here, rounding offs will be little different since 113.42 means 113 is completed and it has entered 114th day. We take it as 114 days. So that is logically we do like that, right? So it is not the usual arithmetic rounding off which we do. It is we have to apply some basic common sense to report this value.
Okay.
All right. So
Yes.
coming to the next question, an oedometer test is performed on a 2 centimeter thick clay sample. After 5 minutes, 50% consolidation is reached. After how long a time? That is, after how much time would the same degree of consolidation be achieved in the field where the clay layer is 3.70 meter thick? Assume the sample and the clay layer have the same drainage boundary condition. Fine. So how will we do it?
We equate T by D square.
Yeah. So we are saying we have to say see here we have been said that the sample and the clay layer have the same drainage boundary condition and the clay is also same, right? So its value of CV is going to remain same, right? Now coming to this part, so 2 centimeter thick clay sample. After let us assume a single drainage condition here, or you can assume double drainage also because it comes to 1 centimeter. So that will be better for calculation. So assume double drainage. So let drainage thickness, that is drainage uh, thickness of drainage layer in lab be DL. So this is 1 centimeters, right? And D in field is 3.7 by 2, which comes to
1.85
1.85
meters.
meters. And TL is 5
Minutes.
minutes. We have to find
T field.
T field for same degree of consolidation. T field is how much? So what we know is CV and TV is going to remain same. So we can equate TV in lab is equal to TV in field. So which implies CV T by D square in lab is equal to CV T by D square in field. So this CV and this CV is going to get cancelled. So this is T lab by D lab square is equal to T field by D field square. T lab is 5 minutes into this, you can convert it into centimeters, which comes to around 185 centimeters whole square D lab is 1 square. How much you are getting?
171 minutes.
$171 minutes, sir.
Yes, sir.
This
Because
is
it's
5 minutes, right?
yeah, it's
And
the
D field is
large
180
value.
185 square.
Hmm. 185 square. Okay.
It will come to more than that, right? In minutes.
One, 171,125, sir. 17,000, 6 digit number. Which unit
180
you want? You want in minutes or?
185 into 185 into 5, right?
Yes, sir. It is a 6 digit
Yeah,
number.
171 125.
125.
You can convert it into days or days first.
Days means 118. 119 days.
171 125 divided by minutes is 1440. 119 days. So what happens if we consider it as single drainage conditions?
It becomes 4 times 119 days.
So it just we will verify it. 5 into 3.7.
Single drainage means in the field or both sides, huh?
Both we have to
Same answer, sir.
same answer. It will
Same
come
answer. Yeah, it will
same.
come same.
Yeah.
You can assume any drainage.
Yeah. So coming to the next question, the time for a clay layer to achieve 85% consolidation is 10 years. The time for a clay layer to achieve 85% consolidation is 10 years. If the layer was half as thick, 10 times more permeable, and 4 times more compressible, then the time required to achieve the same degree of consolidation is. The layer was half as thick, 10 times more permeable, and 4 times more compressible, then the time required to achieve the same degree of consolidation is. How will we approach this?
We replace C by K
Yeah,
by MB into gamma W formula.
yes. Then what will we equate here?
Since the degree of consolidation is same on both the sides,
Yeah,
we
T is
equate.
going to
Yeah,
remain same, right?
yeah,
So U is same, right?
yeah.
So which implies TV1 is equal to TV2,
True.
right? So TV1 TV is written as CV T by D square, right? So if we write it as CV1 T1 d1 square equal to CV2 T2 by d2 square, right? So here what we know is layer was half as thick. That means d2 is equal to d1 by 2, right? This is one condition. And second condition is 10 times more permeable. That is K2 is equal to 10 K1, right? And 4 times more compressible. What is the parameter for determining compressibility in this, which relates CV and everything, which is coefficient of volume compressibility, which is MV, right?
Yes.
MV2 is equal to 4 MV1. Now what we know is CV is equal to K by MV into gamma W, right? Substitute this here. K1 T1 by MV1 into gamma W into D1 square, right? Is equal to K2 T2 by MV2 into gamma W into D2 square, right? So gamma W is going to get cancelled. So let me write here, I will just borrow this space here. So K1 T1 by MV1 D1 square is equal to K2 is 10 times K1, right? And T2 is what we require. And MV2 is 4 times
MV1.
MV1. And D2 is,
0.5 times D1 whole square.
that is 1 by 4 times D1 square, right? Now if we equate, all K1 is going to get cancelled, MV1 is going to get cancelled, D1 square is going to get cancelled, and here 4 and 4 is going to get cancelled. So T1 is equal to 10.
T1 is given, sir.
What?
T1 is given 10 years, therefore 10 and 10 also will get cancelled on the numerator.
That's no,
Okay.
10 is 10, then T1 will be 10 times T2, right?
Okay, sir.
So in that case, if T1 is 10 and T2 will be 1 year. Right?
Yes, sir.
Now coming to the next question. So what is the ratio of permeabilities Ka by Kb of a two specimen of clay A and B with following properties? MV of A is 3.6 into 10 power minus 4. MV of B is 1.8, same units. CV is 3.8 into 10 power minus 4 centimeter square per second. And CVB is 1.9 into 10 to the power minus 4 centimeter square per second. All right. Now we know that CV is equal to K by MV gamma W, and K is equal to CV MV gamma W. All right. So Ka by Kb is equal to CVA into MVA into gamma W divided by CVB into MVB into gamma W. So gamma W and gamma W are going to get cancelled. So here if you substitute the values, CVA 3.8 into all are in 10 power minus 4. So those also get cancelled here. And unit does not matter here since we are going to just calculate the ratios, and units get cancelled. So just we will write as 3.8 into MVA is 3.6 divided by CVA is we have written CVB is 1.9 and MVB is 1.8. So this will be 2, this will be 2. So hence Ka by Kb is equal to 4. Right? Any
Yes, sir.
doubts? Fine. Now coming to the next question. What would be the average degree of consolidation if the vertical and radial consolidation are 20% and 70% respectively? What is the relation for average degree of consolidation?
1 minus U average
1 minus U average
is equal
is equal to
1 minus U radial
1 minus U radial
into
into
1 minus U horizontal.
U
U vertical.
vertical. Right?
Yeah.
Fine. So just you know UR is 0.7, UV is 0.2, then just substitute the value 1 minus U average is equal to 1 minus 0.7 into 1 minus 0.2, right? So 1 minus U average is equal to 0.3 into 0.8. How much you are getting U average?
86%.
86 or 76?
86, huh? Sorry.
It is 76%. So have you ever wondered why UR is higher than UV?
Sir, UR is
UR is usually higher than UV. Why?
because horizontal permeability is greater than vertical permeability.
Yeah. So CV is defined as KV by MV gamma W, right? So CR is KH compressibility in that radial direction and gamma W. So major aspect is KH is usually greater than KV. And another aspect is MV is also little bit lower than M in the radial direction is also little bit lower than in the vertical direction. That is why usually the trend is CR will be greater than CV. CV. Okay.
Okay.
So what will be the effective radius of influence zone made by PVDs arranged in square pattern of side length 1.5 meters? So there are two patterns of arranging PVDs. One is triangular arrangement and one is square pattern. So triangular arrangement is this is one and this is one and this is one and the centers form a triangle. Right? Square arrangement is like this. All right. So the radius of influence zone, what is the relation for square pattern?
Pi r square is equal.
No, if you know the side length of 1.5 meters.
Okay.
So this is I am drawing here square, right? Square arrangement. This square is formed by joining the center of all the PVDs arranged in this particular arrangement, right? So and the side is defines this length of the square or the side length of square is S. So in this case, the radius of influence zone will be 0.565
564 into S.
into S. This is for square.
Uh,
RE is equal to 0.525 S for triangular. So in if it is a square, what is the value? 0.565 into
1.5. 0.847. 847.
0.847 meters. And for triangular,
0.787 meters. 787 meters.
0.787 meters. Right? Okay. Now coming to the next question.
Sir,
Yeah,
can you go back to the diagram?
yeah.
Now here, which we have to go for, sir? Economically, if you want to go for a square pattern or Triangular pattern. Triangular normally only 3 drains are required,
Yeah.
but the effective radius is 0.7 meter. That means
Yes.
water is going to contribute in a 0.7 meters all
Yes.
round.
Yes. Yes.
But in a square pattern, we need a 4 PVDs, one extra.
Mm-hmm.
But slightly, additionally, it's going to cover
No,
slightly.
here what I have described here is usually for just to give a triangular arrangement only. So
Mm.
usually if you see uh, the arrangement of PVDs in triangular portions, right? So it will
Mm.
be like the spacings will not be much higher compared to square.
Mm.
So that is the reason why the uh, effective radius of influence is lower for uh, triangular pattern compared to the square pattern.
Mm.
So that is the primary reason, and it depends on.
Additional
Uh,
factors also.
Sorry.
It depends on some other additional parameters also.
Yeah, it also depends on additional parameters such as these site conditions also,
Site condition, installation charges,
installation charges and
cost
facilities
of
available for installation, and
mm,
this
time.
the strata which is existing
Yes.
apart from the clay layers. If clay layer is found at a particular depth
Mm.
uh, below the ground level, and the overburden characteristics, so that also
Okay.
plays a major role.
Several factors will come.
Yeah, several factors will come into picture.
Okay.
So
Okay.
ultimately, it will govern the economy of
Yes, sir.
installations, right?
Yes, sir.
So there we cannot say what is the uh, provided if you keep all the other factors
Then
same,
only we will come to know.
and only if you compare the radius of influence only, then obviously a square pattern gives us a more efficiency, but
Yeah, yeah, yeah.
that
Correct.
only cannot be a parameter of judgment, right?
Okay, sir.
So it is good that you have opened up this avenue so that people can understand what are all the other factors involved, rather than one dimensionally solving the problem.
Yes,
So I
sir.
appreciate that.
Thank you, sir.
So coming to the next question. So following specifications are given for a clay specimen of 20 mm height placed in a oedometer. So people are conducting some laboratory experiments on a 2 centimeters height oedometer, where they are applying two stages of loading, where initially the vertical stress is 150 kPa, corresponding to White's ratio of 1.3, and when it is increased to 300 kPa, its White's ratio is getting reduced to 1.18. Calculate the settlement corresponding to 50% consolidation. How will we calculate it?
Can you zoom, sir, a little bit?
Yeah, just a minute.
Is it a C1 or E1? Okay,
Even.
E1.
Yeah,
Then can we go for the formula delta H by H is equal to delta
yeah.
E by 1?
That is the first. What we have to do is 50% consolidation, right?
Hmm.
So U is 50%.
Hmm.
So U is defined as settlement at a particular time divided by
Ultimate settlement.
ultimate settlement, right? So we need settlement corresponding to 50% consolidation. That is, we need this numerator value, right? So we know U is 0.5. So 0.5 into
20.
ultimate settlement is what we need,
Okay.
right? So let ultimate settlement be delta capital H. So how will we calculate it? So we know the change in voids ratio and we know the specimen height. So we can use the relation delta H by H is equal to delta E by 1 plus E naught. So E naught is initial voids ratio. For this loading increment, initial voids ratio is 1.3. So if we solve this equation, H is going to be 2 centimeters equal to delta E is going to be 0.12 divided by 1 plus 1.3. So delta H is going to be 0.24 divided by 2.3. How much we are getting? Almost
0.1.
0.1 centimeter, right?
Yes.
2.4 divided by 0.24 divided by 2.3. Fine. So it is around 1.04
Millimeter.
mm. Now delta H small h is equal to 0.5 into 1.04. It will come to 0.52 mm. So this is the answer for question A. Now coming to the second aspect, if the time required for 50% consolidation is 20 minutes, then determine the time factor CV and average coefficient of permeability. So what will be the time factor? So TV can be calculated as pi by 4 into U by 100 whole square. How much we are getting?
How much, sir, for degree of consolidation of how much?
50%, 50%.
So 0.196, I think.
Yeah, same. So these are some standard values, 0.196, 0.848.
Hmm.
So you can directly use, you can remember those values in order to just skip the calculations and save time. So TV is going to be CVT by D square. And here it is almost, it is a double drainage condition. So TV is 0.196. We need to calculate CV. And this is 20 minutes. And D is 20 mm, which you can do it as 2 centimeters. 2 by 2, it is 1. So how much you are getting CV is
9.8
9.8.
into 10 power minus 3.
9.8 into 10 power minus 3. What is unit?
Hmm. Centimeter square per minute.
Centimeter square per minute. Right. Now coming to, we need to calculate the average coefficient of permeability. So K is defined as CV into MV into gamma W, right? So how will we calculate MV?
AV by 1 plus E0.
AV by 1 plus E0, or we know delta E by 1 plus E naught into 1 by
Delta
delta
sigma.
sigma dash, right?
Yes.
So what will we get here?
Table is not visible, sir.
0.12. Yeah, sorry, sir.
Okay.
Delta sigma will be 150. 0.12 by 2.3 into 1 by 150 kPa. How much we are getting?
3.47
3.47
into 10 power minus 4
into 10 power
minus
minus
4
4. What
meter
will we
square
get?
per kilometer.
Meter square per
Kilometer.
kilonewton. You see, if you see here, the unit is meter square per kilonewton, which is exactly opposite of
Kiloliter per meter cube for gamma W.
pressure, right?
Hmm.
So what does it mean exactly? What does MV signify?
It is like a stress in ratio. So.
Stress strain ratio, and
Strain
definitely
stress.
it signifies stiffness.
Yes, sir.
So that's why MV usually it can be related to modulus parameter also.
Hmm.
So now coming to the relation here, K is equal to CV. This part we have to convert it into meter square here. Centimeter square and meter square will be 10 power minus 4, right?
Yes, sir.
So then in this case it will be 9.8 into 10 power minus 7 meter square per minute into MV is 3.47 into 10 power minus 4 meter square per kilonewton into gamma W, let it be 10 kilonewton per meter cube. Alright. So this meter square and meter will cancel, meter cube will cancel, kilonewton and kilonewton will get cancelled. So here 10 and how much you are getting? This will be into 10 power minus 10. Here 9.8 into 3.47. What we are getting?
Uh, 3.34
3.34 into 10 power minus
minus
9.
8.
8.
It is a meter per minute.
Yeah. So 3.34 into 10 power minus
8
8
meter per
meter per
minute.
minute. If you convert into seconds,
5.57
it will be 5.57
into 10 power minus 10
power minus 10 meter
meter
per
per
second.
second.
It is almost, if you see, it falls under the range of
Clay.
permeabilities of clay,
Yeah.
right? So coming to the next question,
Sir, in the previous question, a small doubt.
Yeah,
First part, no,
yeah,
calculate the settlement corresponding to 100% consolidation, 50%.
yeah.
If you don't give 50%, then it's directly delta H only, no? No
Yeah,
delta.
exactly. Yes. Delta.
Direct, simple, it will be simple calculation.
Simple calculation. Yes. It will be
Okay.
1.04 m.
Okay, okay. This is the first time I'm seeing this type of question.
Yeah.
Usually delta H by H is equal delta E by 1 plus C formula we
That
use.
you see, that is where earlier I have discussed, right? So
Hmm.
one part of consolidation, the topic or the concept of consolidation is the
Hmm.
amount which is getting the magnitude of the settlement, which is usually
Ultimate.
total settlement.
Hmm.
And second part is time rate, right? So
Hmm.
this part, question A is one of the examples where we combine both.
Hmm. Hmm. Okay.
So where we combine time as well as the magnitude part,
Hmm. Okay, sir.
right?
Yes, sir.
Coming to the next question, a 3-meter thick clay layer beneath the building is overlain by a permeable stratum and is underlain by an impervious rock. The coefficient of consolidation of the clay is 0.025 centimeters square per minute. The ultimate settlement for the layer is 8 centimeters. How much time will it take for 80% of total settlement to occur? So the table given is for each value of u they have calculated TV. So which you can also do by manual calculations also. All right. So here just if you find if it falls in between any values, you have to interpolate between. So coming to the first question, how much time will it take in years for 80% of total settlement to occur? So 80% in the sense we know TV is equal to CV T by D square. So initially before solving it, just draw the question given. So 3-meter thick clay layer beneath the building is overlain by a permeable strata. So this is 3-meter thick clay layer. Let us consider it. And is overlain by a permeable strata. They are giving just the boundary conditions and underlain by a impervious rock, right? So this is impervious, this is permeable. So what is the drainage? See, it is a single drainage condition, right?
Yes, sir.
So now coming to the first question. So we need to calculate time. So what is the relation which relates time? TV is equal to CV T by D square, right? So TV for 80% consolidation is
5, 6, 7.
0.567, which is evident from the table. It's equal to CV is given as 0.025 centimeter square per minute. So centimeter square, or you can, if you want to convert into meters here, you can do that also, into 10 power minus 4 into T divided by d square, since it is a single drainage condition, it is equal to the thickness of the layer, which is 3. 3 square will be 9, right? So
Yes,
T
sir.
will be equal to 0.567 into 9 into 10 power 4 divided by 0.025. How much you are getting?
3.88 years.
3.88 years. So here you cannot write as 4 years because the scale of time is relatively higher.
Higher
This
it's
3.88 years is you whatever days you can convert it, that will be right. So coming to the next part of the question,
sir.
determine. Yeah,
Here small question.
yes, yes,
Normally in the examination,
yeah,
when they ask answer in years,
yeah.
we have to go for only 365 years, 365 days, default conversion.
Yes,
One
yes,
year is
it is.
equal.
Yes, yes, yes. 365 days. Yes.
Because they don't give that makes any error or not.
No, no, no. Usually it will be 365 years only. Usually
Mhm.
what happens is that in NPTEL courses, we don't give exact answers.
Mhm.
So the answer keys will be in ranges.
Even the range is there, but sometimes a year will be 1 day, 2 day, more will be there. That is
Ah,
not.
yeah, that is in the case leap years are considered. So usually, if this kind of things are considered, it is by default it is 365 years.
Okay, sir, that's all right.
Yeah. So one thing is, in one way, what they can twist is they will give that the loading was started in 2020,
Okay, that is different, sir. That is.
2019,
Mhm.
and it takes you calculate the amount of days it will take,
Okay.
and till what by what year uh,
Yes,
it
sir.
will get
I
completed or something. In that case, you have to calculate, you have to take into account the leap years.
okay, okay.
Usually those type of questions will not, it is not a normal
Yeah.
logical reasoning subjects. So
Yes.
here the basic notion is to understand uh, how to apply the concepts which we have learned. So that, but usually we by default it is 365 years. Month
Mm.
is 30 days.
Mm.
So you can take that, right? So determine the time in days required for 2.5 centimeter settlement to occur. So here coming to the second question, we know that the settlement occurred, the target settlement which we are concentrating is 2.5 centimeters. That is delta H, small h is 2.5 centimeters, right? And the total settlement delta capital H is 8 centimeters, right? So we can calculate U from here. U is defined as delta small h by delta capital H. 2.5 by 8. How much we are getting?
31.5%.
It is 31.25%,
25%.
right?
Mm.
So that is U is equal to 0.3. Let us take 3.1 or 3.1, 3.12 anywhere. So here we have to
Interpolate.
interpolate it.
Otherwise, directly we can use the formula. No? Easier interpolation.
That is also far better in
Yes,
my
sir.
case, because interpolation will take a lot of time.
Yes.
So you, in order to calculate 0.31, you calculate TV is equal to pi by 4 into 0.31 square,
0.0766.
point zero seven
766.
six six. You can just verify here whether this value is in between this and this.
Yes, sir.
So it is in between this and this, and it is close to 0.3, and hence it is logical. So, and also it is the exact value. So in order to eliminate any calculations error, you can just verify it. So TV is going to be 0.0766, right? Determine the time, same. Now coming to the time factor is going to be 0.0766, which is equal to CV is 0.025 into 10 power minus 4 into T divided by this is 3 centimeters, 3 meters, right? 3 square would be 9. How much we are getting? T should be in days.
191.5 days.
191.5.
5, sir.
You can take it as 192 days. It is approximately quarter, 6.25 months. Okay. Now coming to the last question. What will be the settlement in 6 months? What will be the settlement in 6 months? So for that, what we will do? We have to calculate TV now, right? So
Yes, sir.
T is equal to 6 months. Now, so let us write down the values here. CV is going to be 0.025 into 10 power minus 4 meter square per minute, and T is going to be 6 months, and D is 3 meters, right? Now TV is equal to CV T by D square. So CV is 0.025 into 10 power minus 4 into 6 months has to be converted to minutes. 6 into 30, which is days, into hours, 24, into minutes will be 440 minutes per day, divided by D square is 9. You can cancel this. This is 2, this is 3 times, this is 10 times. How much we are getting?
0.072.
0.72,
0.072.
right?
Yes, sir.
So what will be the U value here?
Can you show the tables, sir?
You can calculate from the
Okay.
relations, right?
We don't know, sir. This is less than 60%. Okay.
Hmm.
30.27%.
30.27%.
Uh,
That is 0.303.
3027.
Right? So 0.303 is equal to delta small h by
Ultimate.
delta capital H. Right?
Mm.
So delta capital H is 8 centimeters, right? This is ultimate settlement is 8 centimeters.
Okay.
Now 0.303 into 8 is equal to delta H, which comes to around
2.42 centimeter.
2.42
Centimeter.
centimeters, right?
Yes, sir.
So this is the answer for the third part of the question, right? So with this, we'll be ending this session as well as this series of sessions also. So it was a good learning experience for me, as well as I hope it was you were able to get your concepts clarified. Uh, so all the best for your exams.
Thank you, sir.
Yeah.
Thank you
Dheeraj,
so much, sir.
any comment? Dheeraj, you can make any comments?
Yeah, actually, also, sir, is I also enjoyed a lot, and maybe the same with Mr. ABS. Okay,
Yeah.
so is it possible that we will be touch in future with you in the form of some kind of LinkedIn ID or like that?
So
So
you want my contact details?
yes, yes,
So I will write my email ID in the chat box. You can note it down.
yeah, yeah, please,
Yeah.
please.
So uh, I have written my email ID. You can write to me anytime. So
Thank you
you are
for
noted.
sharing.
Yeah, yeah, sure, sure,
Thank you for sharing the mail.
sure,
And
sure, sure.
also we learned very well the subject. Every day we are writing, we are learning this one, but still there is a lot of updating of the knowledge
Yes,
through
yes, yes.
number of examples and theoretical concepts.
Yeah, yeah.
So this time I was very happy with the entire course, either
Okay.
one from the faculty as well as from both the problem solving research scholars.
Yeah.
So
That's
thank you for sharing your knowledge.
yeah. One more thing is Professor DN Singh is my supervisor.
Okay, yeah, that's also good, good, good. You can personally convey my regards to him. I also enjoy well the course,
Okay, sure, sure.
and he used to give. Now, even though he don't normally solve the number of any examples, even single example he don't solve in the class, but
Yeah, he doesn't believe in solving these
yeah,
examples and everything.
theoretical concept, extraordinary faculties, and
Yeah,
also consultancy the knowledge he shares, and for every line he will write and immediately go to some practical example.
yeah, yeah,
So overall, he makes live the class. Entire class will be live,
yeah, yeah.
and if he is going to give some interaction session at least once in a entire course, it will be very nice directly with us. I don't know it will be possible or not.
Actually, usually the norms of NPTEL is we have to conduct two live interactive sessions, but
Mm.
in last couple of years, what happened is we are also regularly teaching these courses, as we are acting as teaching assistants for these courses. So
Mm.
usually we don't get proper responses during live interactive sessions. So
Okay. Mhm.
unfortunately, it has to be cancelled for last 2-3 cycles.
Yeah, once I attended, sir, 2 years before.
Yeah, so and also the course contents are relatively similar for all the runs. So uh,
Uh-huh.
mm, earlier there used to be large turn up for
Hmm.
discussions, but as those sessions are also already has been uploaded in the
Yes, I
website,
used
right?
to see it. Yeah. Hmm.
So there is no mm,
Okay, okay.
But
Possibilities are this.
there is no scope for further discussions also. People refer to that and they just get satisfied with that. So
Okay.
unfortunately, we are not having much turn-ups for these live sessions. That's why it had to be cancelled.
Okay, okay. Understood, sir. Understood.
Yeah. So
Anyway, sir, thank you, sir. That's very good.
hopefully we will meet for Geotech 2 also.
Sure,
Whenever
sir.
you are registering, and it was nice experience and learning for me also. I thank you
Yeah.
all.
Thank you, sir. Thank you, and all the best for your research program and everything.
Yeah, thank you.
Thank you, sir. Good night.
Thank you very much, sir.
Thank
Sure,
you,
sure.
Dheeraj.
Just stop sharing. So we'll close the meeting.
Yes, sir. Thank you, sir.